Rightio, here we go with part B of the chapter test 4C. Find the gradient and y-intercept of the graphs with the following relationship. So the gradient intercept means we want to get it in the form y equals mx plus c, and m is the gradient, c is the y-intercept. This isn't in the right form. If I subtract 2x from each side though, I would have y equals negative 2x plus 6. Alright, C, but I said 6. There we go. So for that one there, the gradient equals negative 2, and the y-intercept equals 6. Easy as that. This one here, y equals 41x. Well, that's easy. The gradient is equal to 41, and the y-intercept, what number's being added on there? There's nothing, is there? So it must be 0. So the y-intercept would be 0. Sketch the graph of the following linear relations labeling axis intercepts. Here y equals a half. Well, we saw in part A that if I put a half on this axis, and then I want to put another point where y is a half, well, it's actually any point along a horizontal line, isn't it? So the line y equals a half is always a horizontal line, and it just goes through the y-axis at a half. X equals negative 7. Very similar, except instead of being a horizontal line, where's x equal to negative 7? Somewhere to the left here. And everywhere on that vertical line is where x would be equal to negative 7. I should have really labelled this other one back over here, shouldn't I? Last one, y equals negative 9x. So we've got the y-intercept. The y-intercept is nothing because it was 0. And then how do I find another point? We'll have to go down 9 and across 1. That's going to be pretty steep. Something like that. And you could even indicate this point here. When x is 1, it's gone down 9. If you had graph paper, which if we get you to do something in the exam, it'll go like down 9 and across 1. So it would look something along those lines. Sketch the following labeling the X and Y-intercepts. Well, to find the x-intercept, I let y equal 0. So that gives me 3x equals 6, or x equals 2. So my x-intercept is 2. My y-intercept, I let x equal 0. And I've got negative 4y equals 6. Dividing by negative 4, 6 over negative 4, which is, of course, negative 3 over 2, or negative 1.5. I'm going to reposition where I put that to. That's 2 across, 1.5 might be about there. Label that point, negative 1.5. And there I've got 3x take 4y equals 6. The next one, negative 2x plus 7. You count 7 squares up and you put your intercept in at 7 because that's the y-intercept. The gradient is negative 2, so that means I have to go down 2 for every 1 I go across. And you'd show that point, so if I go 1 across, it's going to have an x-coordinate of 1, and down 2 it'd have a y-coordinate of 5. And that would be all you need to do for that one. Alright, let's keep going with the next question. I seem to have scrolled somehow there. Bumping something on the tablet, that's all good. Question 4. Find the equation line which has a gradient in negative 3 and passes through 2, 7. So remember, if the gradient's negative 3, it's y equals negative 3x plus c. To find the c, I sub in the point that we're given. 2, 7. So therefore, 7 is going to equal negative 3 times 2 plus c. So that's going to be negative 6. I've got to add it to each side. I'm going to get 13 equals c. So the equation is y equals negative 3x plus 13. Looks like a funny b, doesn't it? Let's make that look a little bit nicer. I know we're trying to do this quickly, but nothing wrong with making it look nice. Find the equation line which is parallel to this line and passes through 2, 4. So if it's parallel, we've got to figure out what the gradient is. Well, it's nice to get this in the form y equals mx plus c. Some of you may already see that it's not going to make a difference where the 7 is, but let's just do it anyway. So to get y on its own, I have to subtract 7, so I have negative 4x minus 7 equals y. If that's my equation, then the gradient of that line equals negative 4, the number in front of x. So if I want one parallel, I'm passing through 2, 4. So the parallel line is going to be in the form y equals negative 4x plus c. We sub in the known point, which is 2, 4. Y is 4, and that's going to equal negative 4 by the x is 2, plus c, so that's 4 equals negative 8, plus c, add 8 to each side, 12 equals c. So my equation is y equals negative 4x plus 12. Alright, the next one here, the line is perpendicular to the line with the equation y equals a half x plus 6 and passes through 410. So for a perpendicular line, remember the second gradient equals negative 1 divided by the first gradient, which is just the negative reciprocal. So the gradient we're looking for, turn it upside down, would be 2 over 1, which is just 2, and we've got to put a negative in front of it. So negative 2. So we've got y equals negative 2x plus c. Again, we just sub in the point. And the point this time is 4, 10. So it's going to give me 10 equals negative 2 by 4 plus c. 10 equals negative 8 plus c. Add 8 to each side. 18 equals c. So from that we've got y equals negative 2x plus 18. Doing well here. Question 5. Find the equation of the following linear relations in terms of a and b. So that's a x-coordinate of a. So this distance here must be negative a, because a is actually a negative number. So if a is negative, then to go to the right, I've got to go negative, negative a. It's a little bit confusing, that one. Not really what you're going to get on the exam. The height is b, so that's easily found. So this time the gradient is b divided by negative a. And find the following linear relations. Well, the y-intercept is 0, so that's okay. So this is just going to be y equals negative b over a, that's my gradient, times x, and then plus 0. So that's it, just negative bx over a, or negative b on a times x, same thing. This one here, rise over run, well, we go up b, and we go across a units again. It's a little bit confusing because that's going to be negative a, but it's a negative value. I don't really like the way they've written this question. Basically, let's just replace them with numbers and I'll show you what to do because that's more realistic. Let's say that one's negative 4 and this one's 3. Well, then my rise has been 3 and the horizontal distance, even though that's negative 4, the horizontal distance is 4. So the gradient is just going to be up 3 and across 4. So 3 over 4x. Plus, the y-intercept in this case is also 3. So if I was doing it with the a's and the b's before, I was going to have y equals b over a x plus b. But again, a little bit confusing because that a is actually a negative value, so I don't have to have negative b over a, but it's a negative of a negative, and that's just getting nasty, isn't it? And same with the other one over there. It would actually be negative b over negative a. I wouldn't panic about those questions is what I'm really telling you there, guys. I'm actually interested to see what they said for question 5. Let's go down and have a look and see what they've actually said. Yep, negative b on ax, and this one they've called b on ax plus b, which is not actually what it would be because a is a negative number according to them, so that would have messed the whole thing up. If they had have just in their question, back up here, had they just written negative a, would have all been okay, wouldn't it? Because then we'd have a positive gradient, positive b over positive a. So again, if you can do it with the numbers, that's fine. It went up 3 and across 4. Okay, 3 over 4, x plus 3. Problem solved. Question 6. Let's keep going. The line has the equation y equals ax plus b. Give the equation of a line parallel to it that goes through the point CD. So if it's parallel, I'm going to have the gradient equals a. So therefore it's going to be y equals ax plus, well, we want to call it c, let's call it k, seeing as that we're going to have to introduce a c here. So now if I sub in the point CD, that's going to give me d equals a times c plus k, so d minus ac equals k, and that's the bit that I wanted to replace. That's like my y-intercept, so therefore y equals ax plus d minus ac, and that would be the equation of the line. Parallel, so it's got the same gradient, and it's going through CD, well that would make it work. If I now substitute in C, I'm going to get AC, and the minus AC is cancelled, and it all works beautifully. The equation of a line perpendicular to it. So all we need to do is get the gradient right. So the gradient is going to be the negative reciprocal of A, so it's negative 1 over A. So therefore it's like y equals negative 1 over A x plus some sort of constant. And see, I was allowed to say like then because I wasn't using it as a just filler word. I was actually saying it would be like this. It could be anything like that. That C could be anything. It could be 0, it could be 77, could be negative 13.4. Doesn't really matter. All of the equations of the lines perpendicular to AX plus B would have that form. Give the equation of a horizontal line that intersects y equals AX plus B on the y-axis. Well, if it intersects on the y-axis and it's a horizontal line, it's going to have the same y-intercept. That y-intercept is B, so this would just be y equals B would be the horizontal line. Again, these are getting a little bit more abstract. I think the questions in Test 4A are probably a little bit more helpful, or even in the massive revision sheet. If you can follow these, you're doing very well. Finally, this one here, solve the simultaneous equations by graphically by finding the coordinates of the point of intersection. Again, this is what you're doing in your assignment, but very quickly, the second line there has a gradient, has a y-intercept of negative 3 and a gradient of 3, so it's going to go through here, it's going to go up 3 and across 1. So it's going to go through these points. Oh. It would help if I got my little line drawing tool here, I think. Well, it would help if I got my line drawing tool and then drew the line correctly. And it let me draw it through all those points. You get the idea. That looks about right, going through those points. So that would be y equals 3x take 3. The other one here, when it's in this form, it's a little bit harder to deal with, but you just find the intercepts. That's usually the easiest way. So if I let x equal 0, 2y equals 12, y would equal 6. And if I let y equal 0, and that's all going to be 0, I'm going to have 3x equals 12 divided by 3, x equals 4, and that gives me the other point. And then I could find where they intersect, but again, you're doing that on Desmos, so we don't need to panic about it too much for now. But where do they intersect? It looks like they're intersecting at the point 2, 3, if I've drawn it accurately, and we can check whether that's right or not. If I stick 2 in there, I'm going to get 6, and 2 times 3 is 6, 6 and 6 is 12. And if I go 3 times 2, that's 6 minus 3 is 3, which is what the y-coordinate is. So you know you'd have it right. That was part B. I'll be back with part C. Ciao.